Let's go ahead and try an example problem to solidify this information. So in this case, let's say that we have this ball and it makes this general trajectory. We have our gravity is negative 9.8 meters per second squared. We're also given an initial velocity of 39.2 meters per second. I don't know if you can see that very well, so I'll rewrite it up here, 39.2 meters per second. And we have an angle of 30 degrees. Now what we want to do is calculate the vertical component of velocity. So to calculate the vertical component, all you need to do is take your initial velocity and multiply it by the sine of your angle theta. So in this case, your initial velocity is 39.2. That's given right here. And then that's going to be the sine of our 30-degree angle, so 30 degrees. Now, if you type this into your calculator, make sure that you're in degree mode. You're going to get that your V naught in the Y position is going 19.6 meters per second vertically. So what this all means right here is that you have an initial velocity that's traveling upward at 19.6 meters per second right here. So I'll put 19.6, and I'm just going to write it as a number there. Now, how do we calculate the horizontal direction? Well, the horizontal direction is going to be your initial velocity multiplied by the cosine of your angle. So to get velocity in the x direction, that's going to be velocity times the cosine of our angle theta. And velocity is, again, 39.2 initially, and this is all going to be multiplied by the cosine of 30. So cosine 30. So the cosine of 30 times 39.2, if you type this into your calculator, you're going to get that this whole number equals 33.9 meters per second. Now remember, we said before that there is no horizontal acceleration. Speed stays the same. So that means right here, you're going to have 33.9 meters per second. But this same speed is acting here, is acting here, is acting here. It never changes. You're always going to have that speed of 33.9 meters per second horizontally. But vertically, it's actually going to change, because vertically, this gravity is changing it. So notice that 1 second, at the first second, we have 19.6 meters per second. But notice that this gravity is going to decelerate it downward. So that means at second number 2, we're only going to be at 9.6 because we just took away 9.8 from this. At second number 3, we're going to be at 0. We're not even going to have a vector. At second number 4, if we add negative 9.8 to 0, we'll be at negative 9.8, right? And then what happens at second number 5? Well, I'm sure you can imagine at second number 5, we're going to have a negative 19.6 meter per second velocity downward. Because notice how we started at positive 19.6, we ended up a little bit less, we got to 0, then we started going negative because our ball is continually decelerating downward. That's how gravity works, and that's how projectile motion in general works, assuming that you don't have air resistance.